Hey now, I'm Greg Livingston, and this is the third and last in the Commune series of 3 podcasts on Gamescape 2015. Gamescape is a summer indie developer showcase in Baltimore, Maryland. Today, we'll be hearing from developers whose games are based on real life. Well, kinda. In that rock, paper, scissors game, players control one of 3 classic objects: rock, paper, or scissors. If you're rock, you have to avoid paper and try to catch scissors. How does that rock, paper, scissors game keep competition even? And how does it keep competition varied? Here to answer our queries is...
Anthony Powell with Philosoplay. I'm a game designer in the Baltimore, Maryland area. And I am currently working on a new project called That Rock, Paper, Scissors game, which takes the core mechanics of rock, paper, scissors and brings it into a new space for multiplayer gaming.
Nice. And before we get to the questions proper, I just wanted to mention both seeing you in person and reading your comments online and even looking at your avatar on the internet. You're a very positive person. It's refreshing.
Oh, thank you. Thank you so much.
Anyway, about that rock, paper, scissors game, I wanted to ask about the flow of multiplayer, how you keep competition going, how you keep things interesting and also fair. So to start out, I wanted to ask, that rock, paper, scissors game is a 3-player game. You have a rock player, you have a paper player, and you have a scissors player. And so for the rock player, the paper would be the predator element, the element that they're running away from, and the scissors would be like the prey element, the element they try to catch up to. And I was wondering how players generally respond to their prey element. How do they get them?
Oh, so basically, it what I found was that a lot of gamers who are playing that rock paper scissors game find that it's really about strategy. The characters are all evenly balanced in terms of the pace that they move and the damage they can do to their prey and the damage that can be done to them by their predator. So really, it boils down to one of the most purest psychological of games, where players are really just trying to psych each other out and trying to predict where their prey is going to end up and try to meet them there, because the goal of the game is, as you explained, if you're a rock, you have to smash into scissors but avoid paper at all costs. And there's some interesting things that I see players doing in a game like this. One of which that I just mentioned, where a lot of predicting takes place. So like rock has to kind of look at the entirety of the room, has to kind of sort of see where paper is and see where scissors is, and as rock is chasing scissors, rock kind of has to guess, okay, scissors can only move in so many spaces. Which one am I going to choose to try to meet them head on at and then smash into them? And so and this is taking place for all 3 players simultaneously. And there's this weird synergistic train of thought that's going on between the 3 players when they're chasing each other around and stuff. So it's pretty interesting.
When you say synergistic, you mean because they're all observing the same game space and are aware of what the other player could be thinking?
Precisely. And it's just really, really strange to see players sort of linking each other's minds together and trying to read what the other player is going to try to do. And most of many of the times, I mean, the players that are the most successful are the ones who can read the other players the best and either try to meet a player head on or throw the other player off of where they're intending on where they intend to go. So rock is always trying to fool paper in terms of where paper may predict rock to be in 3 seconds and stuff.
I gotcha. There's some clever... it's not just a player chasing their prey element. They can also seek to fake out the people chasing them, or the person.
Yeah, exactly. Yeah, that was unintended an unattended gameplay element when initially designing the game. Like I was just thinking of it as like a very crude way of playing tag, where you're just trying to chase the other player. But I find that the most successful players in that rock paper scissors game are ones who are particularly good at predicting where the other players are going to end up and meeting them there, and also psyching the other player out and stuff.
So have you ever seen like a rock paper getting scissors to kill paper for him?
Yes. Oh yeah. Yeah, absolutely. So we have that quite often with people who just start off playing the game, but they quickly forget that it's the player who has the highest score at the end of the match that wins. So by if Rock allowed Scissors to get paper, then Scissors would most likely be the winner at the end of the match because they have the highest score. And so I gotta constantly remind you players, remember, it's the player who has the highest score at the end of the match that wins. So you want to ruthlessly go after your prey while tirelessly avoiding your predator. You know.
I gotcha. That's an interesting way of keeping the game engaging.
Yeah, thank you. And it's funny because yeah, with this kind of mechanic, you end up protecting the person trying to kill you. You know,
Yeah,
so you
that's got to
have
be
to.
a funny balance.
Yeah, it really is. I think that's where I guess the game might get some of this novelty from. Is you're constantly trying to kill the player that's trying to kill the player that's trying to kill you. You know.
Yeah, actually, you don't see too many multiplayer games geared three-way. You know, you might have like a shooter where you might have squads with multiple people, but it's still two main squads. I don't think I've seen too many games that pit three players against each other equally.
I'm sure they're out there. I can't think of anything off the top of my head. It was really the pure mechanics of rock paper scissors that inspired me to want to make that rock paper scissors trio mechanic, along with like navigation inspiration that came from Pac-Man and Snake and Tron and things like that. And I get those a lot as well. Like, this is just like Pac-Man. I'm like, yes, yes, it is.
Yeah, it's really clean, simple movement.
Yeah. For basic four directions, I did initially start off with allowing the players to move freely in the level, but that really got uh, like it wasn't as challenging. I mean, it was very challenging to try to escape, because players can chase you in any direction. It just wasn't as fun as uh, having players move in only four directions. You know, it seemed to be a lot more challenging to attack a player because you're limited in the amount of directions you can go. And likewise, it's a lot easier to pick up and understand how to move around and stuff.
Okay, that's a subtle distinction that you had to keep things balanced between the predator and their prey by modifying, just by taking out diagonal movement.
Yeah.
So there are also items that players can collect in the game, right?
Uh-huh. There's power-ups in the game. Right now the game is going to ship with 9 power-ups. You have like landmines, invisibility, dashing, invincibility. You have a printer that can clone copies of yourself, a big warhammer, laughing gas, lightning strike, and a pickpocket power-up as well, where you can steal points from other players.
Oh, so how did you balance items against players without items?
Oh man, a lot of hard work. I mean, the power-ups were easily the most difficult thing that I've ever had to implement into the game. I mean, just trying to keep them all balanced and having power-ups that can negate other power-ups and stuff. Like I really wanted that. I really wanted the power-ups to be characters in of themselves as well, to the extent in how they have a relationship with the other power-ups that have been selected by players. Like like for example, if you are being, let's say if you're being chased by a person, like if you have invisibility and you're being chased by a character who has the ability to pickpocket you, when your character turns invisible, the pickpocket, the player no longer knows where to pickpocket. So even if they're close to you, they can't steal your points away from you because they don't know exactly where you are. Or for example, if someone uses the lightning power up against you and they create like a big lightning storm cloud above your character's head, and the lightning doesn't know where to strike because your character is invisible and stuff. And just little things like that make the game play much more interesting when you're choosing which power up you should use and stuff. And also trying to keep the power up balanced by not dedicating any power up to any given player. Basically, the three players get to choose which power up they want to have in the match, and they after they used it 3 times, or if they successfully killed the player with the power up, or if they died, they end up losing the power up, and it goes back into a level for somebody else to grab. And so, I think with those mechanics so far, the game seems balanced between all the power-ups and stuff. But it's been very, very difficult to try to achieve that.
Okay, so it sounds like each of the power-ups interacts with all of the other power-ups, maybe in a subtle but also meaningful way.
Yeah.
And it's also not, power-up isn't an automatic win in that you need to be skillful with it. You only have 3 uses and you lose it if you die. So it's not like the odds are unfairly stacked against the player without a power up.
Yeah, that was the hope to try to achieve that. There might still need to be some work done on that, but I keep finding new things to tweak with the power ups. It's pretty interesting.
One thing I wasn't clear on, so do players purposely choose power ups?
Yes, you can choose before the match starts one power up to bring into the level. So there'll always be 3 power ups available in the level, and players can just basically they'll just be sitting on the ground, and a player has to run into it in order to obtain it, and then they would have to push the action button or the power up button to use the power up. And then, or they can discard the power up and then pick up a different power up that they run into on the ground. And so it keeps the power ups moving and flowing and stuff. You can end up using all 3 power ups at different times of the match, and it just keeps it all flowing. And that was just because we had landmines in the game. That was one of the first power ups we added, and we found that it was quite unbalanced, that players were able to just lay landmines all over the level and just take out their prey constantly. So we decided to limit it to just 3 landmines, and you lose the landmines the moment you successfully kill your prey with that landmine and stuff. Or you can discard it, or if your character dies, you end up losing those landmines. They go back into its original place, and another player has to smash into it to grab it. And they can use it.
Okay. So is that to say that a player might, I might see my friend pick landmines, and so I choose the lightning because I think that's going to be good against landmines?
Well, it would most likely be chosen because you would pick the lightning because it's something that you can attack your prey with without having to step on a landmine.
Yeah, okay.
So, yeah, but let's say if you pick the dashing instead of the lightning, then you could while trying to attack your prey dash and step on a landmine and then end up blowing up and stuff.
Okay, that makes sense.
Yeah.
And so when a player is losing, how hard is it for them to recover? Do winning players gain a significant lead, or is the match pretty even throughout?
Well, actually, it's funny that you mentioned that because about midway through development of the game, we realized that if a player is actually really good, they can annihilate the board. If they're that they are good at both evading and chasing their predators and prey, they could really get a serious points advantage. So one of the things that we had implemented, we had it turned off for simplicity's sake at the Gamescape and other events, but we have special attacks where underneath your character's HUD there is a critical meter that's blue, and the more kills you get, so for every kill that you get, it goes up 25%. I'm sorry, 15%, and every time you die, it goes up 30%. So if your character is continuously dying, and which would mean that the opposing player, your predator, has a very large lead on you, then you can unleash a special attack. And if you can land that special attack, which is unique to your player, then it'll give you extra points, more points than you would get if you were to use a power up. And so that's sort of that's the best way that we have for balancing that out and stuff is by it's not a sure bet that you can land or you can take out your prey with that special attack to give you extra points. But if you can, it will balance it will give you a higher point increase than you and it would make catching up a lot easier.
That's an interesting consequence where naturally I'm going to want to go after the other player and get them as often as I can, but in so doing, I gave them fodder for a counterattack.
Yes, exactly. Now, it's not to say that the counterattack will get you every time. You do have a lot of many chances to avoid or evade the attacks. But if you do get hit, then you'll have to work a little harder to try to get that lead again.
Okay, cool.
Yeah. Okay.
And so one last question, more conceptual, I like to run by everybody. When it comes to game design, not just in that rock, paper, scissors game, but in general, talking about games, what do you consider more important? The game itself, the intention of the developer, or the experience of the player?
Well, that's actually really good. I would probably say, is it possible I can give two answers or?
Sure, it's just however you like to answer.
Alrighty. Well, I will probably say, it's like the intentions of the game developer are all well and good, but it always comes down to execution. And if the execution of the game is good, which is like the design is good, then that matter that makes a huge difference. But it's ultimately, I guess, up to the perception of the players and stuff, you know. So I can try to design the best local multiplayer combat game I can, but it's really in the eyes of each player who plays it that determines how good it actually is and stuff, you know. So I think, it's hard. I would have to go between the first and the third. I'd probably have to say that it is ultimately, it's ultimately up to the players that will determine what's the most important about your game is how the players see it and stuff, how they respond to it.
Okay, it's and
that's such a good question.
It's like an indirect communication where you, the developer, or some developer makes a game, and then the developer hopes that the game communicates whatever idea to the player on behalf of the developer.
Yeah.
All right.
Absolutely.
Well, thank you for joining me. This has been an insightful interview.
Thank you. Thanks so much for having me. I've been waiting all week for this interview. It's great to finally happen.
Yeah, same here. I also just realized I forgot to ask if there was anything you would like to plug.
Yeah, so if anyone's interested in finding out more about that rock paper scissors game, you can check us out at facebook.com/Philosoplay, which is PHILOSOPLAY. Also, you can check us out at twitter.com/Philosoplay and youtube.com/Philosoplay as well. And we also have a Steam Greenlight campaign where we're trying to get as many votes as possible so that we can get our game onto Steam. And if you want to check out the Steam campaign, you can just go to our Facebook page or our Twitter handle, and in our description on Twitter has the link for that rock paper scissors game Steam Greenlight campaign. So thank you so much, y'all. And my name is Tony Powell with Philosoplay.
Nice. Thanks for sharing. That discussion with Anthony Powell reflects on a discussion we'll have about multiplayer balance in Splatoon. That's upcoming in episode 50. Immune defense puts players in control of your immune system, turning molecular biology into a real-time strategy game. Here, developer and PhD Melanie Stegman discusses the transition from specific, complicated biochemical functions to an entertaining, playable game. So, without further ado...
I'm Melanie Stegman. I'm the owner of Molecular Jig Games. And, I'm a biochemist. I studied hedgehog signaling for all you biochemists out there. It's a really important pathway in development and tumor development. So I used to talk to people about what I did, and nobody understood it. And they didn't even understand the basics. So I wanted to go into research. So education, how to educate people better. I got an NIH grant. I made a video game for a nonprofit think tank. We found that it teaches. We published a paper. And now, in the last year and a half, I've spun off my own indie game studio, and we're making Immune Defense, a biochemistry strategy game.
Nice. I have to admit, playing Immune Defense made me feel a little weird in that, watching your own cell die and then having to eat it, that touched me emotionally in a way I wasn't expecting.
Yeah, I wasn't expecting either that people get really upset when that first neutrophil dies.
Yeah.
Yeah.
So immune defense is based on real biochemical functions, I guess you would say.
Absolutely. It's all biochemistry.
And what difficulties were there in translating that? I guess I think of it as like textbook stuff, but what difficulties were there in translating that sort of specific science-y stuff into a video game?
There were plenty of difficulties. The most recurring difficult problem is convincing the development team, who at the very beginning had much more experience than I did about games, convincing them that, yes, this level of detail was actually going to be fun. So what happens is basically white blood cells have tens of thousands of different receptors on their surfaces. They're just like covered, crawling in proteins, so many different kinds. And what I did was I simplified the cell, so now it has 3 possible surface molecules at any given time. Just 3. You can change them, so there's 15 total in all the different combinations, but there's only 3 different kinds. And still everyone's complaining, well, but it's still, complicated.
Yeah, well, even with 3, it gets pretty hectic.
Yeah. We've gone from 10,000 to 3. Yeah, it is. It's really complicated. So we've done 2 things to make it less complicated, and that is, 1, start off slower with fewer things to do. And the second thing we do is add more, I guess you call them attaboys, and more feedback and more shiny glowy things, and more feedback. Basically, when you click on an E. coli, it should glow, and you should know you've selected it. Every little tiny thing that you do in the game should be more fun to do. Okay, so going back to the beginning, making it more simple. When I first started making the game, we started out, we had cells and E. coli and proteins and all these things on the field, and if you wanted to know more, you could click on them, and the data panel on the bottom right of your GUI would tell you what they were. And I had no idea, and the people I was making the game with also had no idea that it was going to be so hard for anybody to figure out at all what the cells were, the proteins were. So we spent about a year backing up, and making the gameplay simpler, so that you start out with just a bacteria on the field, and it's the only thing there, and all you have to do is click on it to identify it.
You can see it in the demo online. The first 6 levels there ramps up in complexity pretty nicely.
Yeah, I really wanted everyone to come away with the idea that this is a real game, that it's fun. Fun was number one. I wanted it to be another strategy game that will keep you occupied for hours and keep you really engaged, because it's always interesting. What else can I do? What else can I manage? Or what else am I going to have to fight? What other bad guys coming around the corner? I like that about strategy games. So I have to apologize. I've been up against a deadline for the past 2 days. I feel like my brain is all over the place.
Is that what it's like being a researcher?
It's not research at the moment. I just got a new technical artist, game developer on board. He's going to be my partner, making the commercial version of Immune Defense.
Oh.
Yeah, and we have these talks. He's like, well, as long as the design plan is really well defined, and it'll, it's something we can do in the nights and the weekends, and we can get this out in about a year. And of course, I'm like, oh yeah, it's totally well defined, it's all nailed down, really concrete. And so for the past 3 days since I spoke with him, I've been, deciding, like, I'll have 3 possible options for what should be on the GUI, and like this is what's going to be on the GUI. I've got 3 possible options for, what zoom state we use, 1 micrometer, 100 nanometers. Okay, these are the zoom states we're going to use. So I've just made 10,000 decisions in the past 3 days. So I'm sorry.
No, I can understand. As a programmer by trade, things are more often than not 10 times more complicated than you think they'll be.
Oh, it's really true. It's really true. One of the things I've learned in the past 8 years of trying to make a video game about biochemistry is when I think I've got it simplified, and I think there's just just 1 or 2 options, and I'll ask the programmer or artist which one they think would be great. Involve the team. And usually the stress of having to make that decision is so much more stress. No one really feels more engaged because I've asked the question. They really just kind of feel like freaked out. 'Cause they're like, yeah. And a little more so too, because it's like we're talking about E. coli and what they're supposed to look like. It's not like we're talking about X-wing fighters that everybody's familiar with or that kind of thing. So it's a little bit like nobody wants to tell me what they think E. coli should look like because they don't want to screw it up. You know what I mean? There's a added pressure there.
So do they look to you as the expert?
Yeah. Which is great and horrible because I'm like an expert on E. coli. I know exactly what they look like. I know exactly why when you take a picture with a microscope of an E. coli, why it doesn't look right and how we should correct it in our art. But I keep getting confused between the word material and the word texture. I'm barely holding on to the word JPEG and TIFF. And so there's a giant gap between us when we try to communicate. Our Venn diagrams of knowledge barely overlap.
Huh.
And it's very difficult. It's really, really difficult. And it's odd that in 8 years, it's getting better, but it's such a slow pace.
You two are, the 2 factions are starting to meet in the middle, maybe?
I feel like I've worked with several different developers to make the version of Immune Defense you see now. I've had 3 major programmers and 2 sets of artists, and it was mostly a company called Cosmocyte that I hired with my grant money from the NIH. And I've learned a lot. And the programmers, Alex Sladen, I think he knows immunology now better than I do. Yeah, because he's got it all coded. He's like, well, E. coli do this because that's how I coded it. Staphylococcus, can divide outside of cells. That's how I coded it. So he's like created a whole immunological situation.
Weird. So instead of someone who's simply studied what E. coli does, he's actually made a virtual E. coli and knows it from the inside out.
Yeah, yeah. I told him what E. coli does. He coded it, and so he really knows whatever I said about E. coli. He knows by heart. And I know like 10,000 things about E. coli, and he knows 5 that he coded. And so he'll say, "What about this?" And I'll think of all the other things that are true about E. coli before I think of the 5 that we've actually nailed down in the game. And I think it's good that the game is simpler. It's good that we've nailed down some facts. And I've just really tried hard for those 5 facts to be the fundamental core ones you need to know. And I guess I've learned more about technical art and programming, and programmers have definitely learned a lot more immunology.
So when you talk about narrowing down 10,000 things to 5, is that like when you were talking about having having only 3 possible receptors at once?
Yeah. So the cool thing about biochemistry, I'll tell you, the cool thing is that you have an organism or a cell or something, and it has a bunch of different proteins, and you can take one of those proteins away, and now the cell can't do something. There's a function that's missing. Or maybe it gained a function. You remove one protein, and now another protein can do what it was trying to do. So that's biochemistry. You've got an organism, and you poke at it and see what it does. So I wanted to give you a cell that did cool stuff, like move around and kill pathogens and do other things, and things that you could see it doing, things that you could be motivated to accomplish. And then I would let you change what it can do, and by changing the proteins on its surface. So I chose 3 categories of things. One is move, one is get yourself activated, and the other is do your job. So with those 3 categories, you can choose one of 5 different proteins in each category. So you can move with a purple receptor, and that'll let you follow purple cytokines that are leading you in some direction. You could take off all your move receptors, and then you won't go anywhere. You can put on your activation receptor so that any activating molecules in the area will run into your receptor, and you'll eventually get activated. And your job receptor, your first job receptor, is the thing that sticks to E. coli so that you can eat it. That's how I narrowed it down. So in our game, moving, getting activated, and sticking to bacteria or different kinds of pathogens, those are your key things that you need to do.
And those are like pretty simple things that anyone might understand after having played a video game. It's just moving and eating stuff. Yeah.
I'm a true believer in George Fan's method of introducing the things in your video game. So, like, your cell should do what it does. You should see it happen. If you put this receptor on, then the cell should move, and it really works. If the players realize that they're the one that put those receptors on the cell, and then it starts moving, they realize that they caused it to move. And it might take them a couple more times to realize that it's because of the purple proteins in the area. That's why it's moving. But everything that can happen that is visible and available to be modified by the player.
It's good feedback.
Yes.
Basically, immune defense, would you call it like a Cliff Notes of immunology?
Yeah. It's all the things you need to know to enter into any conversation about immunology. So yeah, it's good at Cliff Notes because, like, you know all the characters, and you're going to know all the cells. You're going to know basically all the different jobs the cells do, all the different possible receptors they can have. But there's a lot more subtlety to it. So if you had read the book about immunology, you'd realize that there are thousands of receptors, and you can follow hundreds of different cytokines. It's not just 5 different ones. You would just realize it's a lot more complicated.
Right. It's more like, the introductory chapter than the whole book.
Mm-hmm. Well, it's actually the whole book. Like, a lot of the things that we're presenting to you no one's going to teach you until you go to graduate school for immunology. Like, no one's going to introduce you to a natural killer cell and its actual mechanism of killing. That is not something you are ever going to see in an introductory chapter. It's something that's in chapter 15 or something. And that's the thing about making a video game about biochemistry, and that's really the heart of why there is no other biochemistry video game, because we don't really absolutely know for sure what exactly natural killer cells are doing. You can't really do an experiment on one natural killer cell. You have a plate full of them, and then you're always going to have other things in the environment. You can't really look inside of your tissue and see what natural killer cells are doing. Yeah. And so, well, two things. I picked and chose, what core things, and I made sure that we weren't teaching anything that could be confusing, so that when you do take freshman biology or advanced immunology, the teachers are going to tell you things like, well, actually, these other things happen. And you won't be confused. You'll know the principle that natural killer cells are investigating, and they're looking around and they're trying to find infected cells. And what the teacher's going to end up telling you is all the other ways that natural killer cells have for finding infected cells. And you're going to know, I've got infected cells, I need to find them, this natural killer cell is all I've got to find them, I wish I had some better ways. Then you're going to go to immunology class, and they'll be like, look at all these other ways. And then you'll be like, wow, this all fits. This all works. Does this make sense?
Yeah, it's there's not many games about immunology because even as someone with a doctorate, you're explaining that there are difficulties in translating it.
Yeah, that was the second thing I was just going to say. Is I end up having conversations with other people who have doctorates, and they work on natural killer cells or cytokines, and I say to them, what would one natural killer cell do? And they write to their friends, and there's a whole string of emails where people are going, that's a really funny question. I don't know. Because we talk like scientists. Like, we argue from example. Like, well, when I did this experiment, this is what happened. And I assume it was because of this and this and this. But it wasn't one natural killer cell by itself. Nobody knows.
That's
I'm
pretty
sorry.
cool. No.
Yeah, I think it's cool. I feel like I'm really out of it. I feel like I should have begged off and told you I was tired.
No, this is going well.
Cool.
So next I wanted to talk about the paper you wrote about immune attack. Am I right in understanding that you sent out this game to students in elementary, or I think it was middle school, and studied how much they played the game, how well they performed in the game, and how much more confident they were in reading, I guess you would say, high-level immunology diagrams?
Yeah. What we did was we had them play the game for 40 minutes, and then a week later play it for 40 minutes again, and then the day after that I would give them a test. And we had the teachers would give immune attack to half of the students, and the other half got a different game that didn't teach anything about cells or proteins. And so I was able to find out if my 7th graders or 12th graders, or in between, remembered the names of proteins, the names of cells, remembered what the cell was trying to do, remembered what things you needed to look for in order to get to a certain place to move the cell, and what you were trying to eat. And then I actually wrote 27 multiple choice cell biology, immunology questions, and I had to go to really advanced questions because the kids answered all of them right. So I had to make up some pretty tough questions. Things like, what is the difference between a T cell and a neutrophil? And, the answer is that cells differ because they have different proteins. Their DNA is the same, they have different proteins. This is a standard that everybody's supposed to learn in high school. Yeah. And if you meditate and think about it for a little while, you can remember that. But you've never really thought about the difference between a protein and a piece of DNA. Like, it doesn't really mean anything to you. But if you've played the game and realized that your cells really are different because they have different proteins on them, then that question's easier to answer. So we found that the kids that played Immune Attack could remember the names and the concepts. They knew that the thing they were supposed to be finding was a protein, it wasn't a lipid. And then when I showed them these complicated diagrams from immunology reviews, Nature series of journals, the kids that had played Immune Attack answered that they thought they would be able to understand this complicated diagram. So I didn't ask them what it was about. I just asked them to say, on a scale of 1 to 5, do you think that you could understand this if you read it?
Right. If I remember correctly, you phrased it as they were more confident.
Yeah. Because most people ask, do you want to be a scientist? And most people ask, do you like science, or do you think a science career is for you? And that's all good and everything, but what is science? What I wanted to know was, do you think this stuff, these cells and proteins, these things that you've just been playing with, do you think they're something that you can understand?
And that's just with 2 40-minute sessions.
Mm-hmm.
Man.
Yeah, it made a huge difference. Statistically significant. And the difference was bigger if the kids reported being game players. So if they played 1 to 20 hours a week, they were more likely to be confident. And then the kids who did not play games did not gain confidence. They didn't lose confidence, thank God, but they also didn't gain confidence. So when I looked at learning, I compared the kids who reported 0 hours per week of games versus 1 to 5 versus 5 to 25. And with learning, all the kids learned significantly more than the controls. So that was nice. Even the kids who said, this game's hard to play, I don't play games, and those kids also, none of them gained confidence, they still learned.
Yeah, just by being exposed.
Yeah. So the game still taught them and did not take away their confidence. Like, Immune Attack is a much different game from Immune Defense. So you can play Immune Attack at immuneattack.org. It's PC only. It's a flying game. It's third-person shooter. You play inside the body. You have to use your keyboard and your mouse. And it's a lot for someone who doesn't game, to be right-clicking and driving the ship around inside the vessel.
Yeah, that's some serious hand-eye coordination.
Yeah, exactly. And you only have 40 minutes, and you're in front of all your friends, and it's pretty stressful. So I was really afraid that the non-gamer kids would be like, oh God, immunology is so hard. Keep crashing and burning all the time.
Is this what grad school is like?
That is what grad school is like. Yeah. So they did not lose confidence, and they gained confidence. So I was happy.
Well, that's good.
The other thing that we knew is they were learning everything we threw them. Everything they had to find, they could remember the name of. They knew neutrophils in that game were green, and they did not know things that they did not need to find.
So I wanted to ask, on the topic of teaching, how are Immune Attack and Immune Defense different from stereotypical, quote-unquote, edutainment games?
Well, it's really easy. Most learning games are marketed to the teachers and to the schools. And if you need the school to pay you money, you need to do what the school wants in order to sell your product. And my product is marketed towards you and the 7th graders and me, people who like games. And I'm not going to pay you if it's not fun. I might pay you for my kid to play it if I think that they might do it. But, basically, I need to be fun, and learning needs to be in there. If you're going to market a game to a school, the teacher needs to know exactly what the kids are learning and exactly how much time it's going to take. And they basically need an output device. They need a test at the end that they can say the kids answered these questions, therefore they know these answers. And we don't have that. Immune Attack was built with there's no questions in it. There's no test at the end.
You might say that the test is the gameplay, just succeeding.
Yeah, you can say that, and that's great. And actual regular people believe that. And so people are going to buy Immune Defense because they believe that. They're like, oh, I played this. But teachers can't rely on that. They can't say like, oh, well, they played some level with neutrophils in it, so now
Right.
they... Yeah, yeah. And teachers also don't have time to play a video game. It's like if you're a game reviewer, you spend a lot of time playing games, and you want a cheat code, damn it, so you don't have to beat level 3, so you can move on to level 4. And it's the same with teachers. They don't have time, to play every level of all these games. So what they really need is straightforward. Here are the standards. Here's what's being taught. Here's the tests that the kids can take, and so what you end up with is a real edutainment kind of game, where it's pretty fun to play if you're trapped in school, but it's not that fun to play if you're not trapped in school. Yeah, and I really wanted Immune Defense to be fun from the beginning, and so I play tested it with kids. And at first we were testing in school, and we were like, wow, they love this game. And then you test it outside of school where, they're not forced to sit. And you find out that you've got a long way to go in the fun department.
Yeah, real-time strategy games. I mean, yeah, they're kind of complicated.
Yeah, they are complicated. And that's another thing that I'm, battling with. I really am aiming for a mid-core game. And we have a pretty decent hardcore game. But I want it to be something that the average person will pick up and play, because I want the average person to know what proteins are and what receptors are.
Yeah.
Yeah, so I'm redoing the GUI. That's the major change we're making in the game, so that you click on a cell and the menu pops up right next to it. There's no, you don't have to use your strategy game GUI where the data shows up way down at the bottom. We're going to let you click on it and get the data right next to it. And we're also changing it up a bit so that you can see the molecules that are on the pathogens, and you can see the molecules that are on the cells, and you'll be able to see the interactions between them. And then those two things are going to make it more of a mid-core game. Still complicated. All the interactions, all the things you do are still really complicated, but following the George Fan principle, things will be there and you can see them working and having their effect.
Yeah, that sounds like it'll make it a lot easier to get into when,
Yeah.
if I can click on something and see my options as opposed to having to parse this bar at the bottom of the screen.
Yeah, it's really true. And it's really funny because people who see the game and like it, they're the strategy gamers. If they've played StarCraft backwards and forwards, they're like, oh my god, this game is awesome.
I think I played all of 2 missions in StarCraft.
Yeah, I know. I know. I actually was talking to someone who judged the game at a thing, and he voted no for the thing, and he felt really bad because all these people were standing around enjoying it at the thing. We got in, and he's like, I didn't like it. And I'm like, do you like strategy games? He's like, no, I've never played them. I'm like, well, there you go. Yeah. Yeah. So it's a trick to take complicated stuff and make it really mid-core without really simplifying it. I really want you to feel like it's cool, neat, intricate, but I don't want you to just be like, well, there's 2 buttons, I'll just push one and see what happens. I want you to think or feel that you're making some kind of informed decision.
It's that sweet spot where you have the player engaged.
Yeah, yeah, it's a sweet spot.
Okay.
We're also thinking with that we'll have a tablet version that might be simpler, might have a much more just get the cell to go here and go there, and not really worry so much about all the details. So we'll hit a broader audience. We'll sneak this knowledge of receptors into many different formats.
So I was curious, do you know Jesper Joule?
I looked him up because you mentioned him.
Oh.
Yeah.
So yeah, he's this guy that writes about video games, and he has this neat idea that games are, he says, half real, where there are real rules because when you play Space Invaders, you shoot an alien, you actually, there are points in the game that accrue, but you're playing Space Invaders, and so the half real part is that, it's not actually space aliens inside the arcade cabinet.
Yeah.
So with immune attack, you simulate, or actually with both immune attack and immune defense, you're that fake half is kind of not fake anymore because now you're simulating factual interactions.
Yeah.
And, I was wondering if you had any thoughts regarding that barrier between fiction and reality.
Yeah. I have a lot of thoughts about that. Really a lot. Because a lot of people, like their first gut reaction, well, first of all, every single person says, is it for fun or is it for learning? Every single person. There's a giant division apparently between fun or learning. And then a lot of people say like, well, if you keep it real, it won't be fun. And then I always say, what if we were making a Star Wars game? And if I made the Death Star really close to Tatooine, you would be outraged. And I would say like, well, it's more fun this way because it's easier to get to the Death Star. And you would be completely outraged. So like there's a reality there that matters, really, really matters to everybody. And it's imaginary. Like even your Space Invaders guys, they all go in the same direction. If they went in different directions, it wouldn't be the same game. And so it is imaginary, but even the imaginary part is rigid. There's always like rigid bits. And so I really think that the fantasy worlds that we develop, as soon as it's developed, it's got rules. It's still fantasy. It's not really there. It's just pixels on a screen. But those worlds are complete with governments and rules and languages and instantly as soon as we make them. And the thing about molecular biology is it's a world. It's a giant, fantastic inner space. It's like Middle Earth. It's somewhere that's really hard to define where it is. But there's all these characters that have different traits and different jobs, and there's tribes of them. All the purple receptors bind to cytokines, and they're always going to do this one thing. And it's a whole new fantasy world with its rules and randomness and things that happen for different reasons that we can't relate to because we're not in that world. And that's why I really think I've basically made a fantasy game. A brand new strategy game in a fantasy world.
You've taken biochemistry and given it the allure of, Tolkien backlore.
Mm-hmm. That's what I really think. Like, nobody really wants to play another dwarves-based strategy game. We need a new strategy.
Yeah, where's a Dwarf Fortress? Or, Protein Fortress.
Yeah, Protein Fortress would be awesome. I've got Dwarf Fortress. I met the guys that made it. They loved immune defense.
Oh, nice.
That was so awesome. I know. Yeah. I was like, so all the geeks in the world really like immune defense. Yeah. Scientists love it. We were at Gamescape in Baltimore, and like 5 different groups of people. Cause Gamescape is an add-on to a festival called Artscape in Baltimore, Maryland. So we get a lot of people there who are not gamers, and they wander in and they're like, "Oh yeah, I'm going to med school here at Johns Hopkins," or I'm a nurse at the hospital, or I'm doing research. We had 3 different groups of graduate students and postdocs who were like, "Oh my God, there's TNF! Grab it! You need to actually."
That's amazing.
Yeah, it was really awesome. Really awesome. Because, the big cool guys with the party games, they're all like, what's going on over there? What's that strategy game getting so much attention?
That didn't even hit me that Johns Hopkins is right down the street there.
Yeah.
That's so cool.
Yeah, you got to know your audience.
So one last question before we part. This question is about just game design in general, not necessarily related to immune defense or immune attack in specific. When it comes to game design, which do you consider more important? The game in itself, the intention of the developer, or the experience of the player?
I can't get past the experience of the player. If I make a game and you don't like it, then it's not a good game because you don't like it. It really doesn't matter what I think of it. It's sort of like the color red looks pukey to you if the color red looks pukey. So if you don't like my game, then you're in a world where this game is not fun. And when I play a game, if I don't like it, I don't care what the developer was trying to do. Yeah, and I think this is the simplistic version, of game philosophy. This is like, the simplest interpretation of this literature version is like, well, if there's no fun, then I don't like it. Like I played Papers, Please, and I really like what the author was trying to do. It was really neat, putting you in someone's shoes and letting you see how things work. But I hate filling out forms. I hate comparing numbers. And you need to correctly identify numbers and match forms in order to get to the cool parts where you get to lie and cheat and take bribes. And so I didn't like the game. Yeah.
It's almost actually getting back to your response about the difference between the immune games and edutainment games, that in your experience people were learning better if it was actually catered to them.
I don't exactly know what you mean, but...
So, like, how an edutainment game is typically marketed towards a school, whereas the immune defense game is geared more towards the person who's actually going to be playing it. So
yes.
it would count the experience of the player as most important.
That is absolutely true. That's absolutely true, and I don't think I made that point as clear as you just did. But people definitely learn better if the game's engaging, if it's repetitive, they have to do the same thing several times, that kind of thing. And if they want to do the same thing, if they go back and replay it, or explain to their friend how to do it, or make fun of the next guy who can't manage it. Like, if it's so engaging, you don't want to stop watching the computer even though it's not your turn anymore. You're going to learn more, and that really happens.
Nice.
Yeah. Player experience is everything.
Well, it's been good talking to you.
Thanks.
Oh, actually, before we go, I should ask if there's anything you would like to plug.
Oh, yes, I do have something I would like to plug. Immune Defense, is still on Indiegogo. You can go to immunedefensegame.com, and you can find all about our game, and you can still buy advanced copies for $10. And for $15, you can get a copy of every game I make in the future. So when I make that new MMO that takes place in the molecular world, you get to play an enzyme, you'll get a free copy. Yeah, Molecular Jig games. We need you.
Nice. Well, thanks for listening. Next time we'll get back to our regularly scheduled programming. The next game we play is the Sega CD version of Pop Full Mail, which I don't think a single one of us liked. Oh well. If you have any comments or questions, please email vgcommune@gmail.com.